Hello, I'm Mrs. Ruma Dhanmate from Aryant College of Arts, Commerce and Science, and in this video lecture, we shall see the importance of software architecture to an business enterprise or an organization. An architecture will inhibit or enable a system's driving quality attributes. Second point is the decisions made in an architecture allows you to reason or justify about and manage change as the system evolves. Third, the analysis of an architecture enables early prediction of the system qualities. Fourth, a documented architecture enhances communication among the stakeholders. The fifth point is the architecture is a carrier of the earliest and hence most fundamental, hardest to change decision designs. An architecture defines a set of constraints on subsequent implementation. And the seventh point is the architecture dictates the structure of an organization or vice versa. Eighth point, an architecture can provide the basis for evolutionary prototyping. Ninth point, an architecture is a key artifact that allows the architect and project manager to reason about cost and schedule. 10. An architecture can be treated as a transferable reusable model that forms the heart of a product line. An architecture-based development focuses attention on the assembly of components rather than on their creation. 12. By restricting design alternatives, architecture channels the creativity of developers, reducing design and system complexity. And the last point, an architecture can be the foundation for training a new team member. These were the 13 points which shows the importance of software architecture to an business enterprise or any of the organization. We shall see all these points one by one. The first point, inhibiting or enabling a system's quality attributes. Whether a system will be able to exhibit its desired or required quality attributes is substantially determined by its architecture. It means that if the architecture is good, then it will give you a proper software or a project. That means the end product will be good if the architecture is good. Next point, if the system requires high performance, then attention must be given to managing the time-based behavior of elements, their use of shared resources, and the frequency and the volume of inter-element communication. Next point, if modifiability is important, then the responsibilities should be assigned to elements in such a way that majority of changes to the system will affect a small number of those elements. It means that if you want to modify your project or a product or a small function or a module, so if you are making changes to a function, it should not affect everything in your system. So you should manage the change in such a way that it does not affect the whole system, or it should affect only small number of elements. Of the system must be highly secure. That means if you want the system to be highly secure, then you need to give the authorization mechanism, that is for inter-element communication and control. Of the system must be highly secure, then you need to manage and protect inter-element communication and control. That is, you should have authorization mechanism. If scalability is important, then carefully localize the use of resources to facilitate introduction of higher capacity replacements. If the projects need the ability to deliver incremental subsets of the system, then carefully manage intercomponent usage. If you want the elements to be reusable in other systems, then you need to restrict inter-element coupling. The second point, reasoning about and managing change. Now, in this, there are three categories. The first is local, second is non-local, and third is architectural. So every architecture partitions possible changes into three categories. Local, it can be accomplished by modifying a single element. Non-local requires multiple element modifications but leaves the underlying architectural approach intact. Architectural. Architectural affects the fundamental ways in which the elements interact with each other and will probably require changes all over the system. Third point, predicting system qualities. Architecture not only instills systems with qualities, but it does so in a predictable way. It is possible to make quality predictions about the system based solely on an evaluation of its architecture. That is, if your architecture is good and you want certain qualities into it, so you need to make an architecture in such a way that after its implementation, it gives you what you have predicted. If we know that certain kinds of architectural designs lead to certain quality attributes in the system, then we can make those decisions and expect to be rewarded with the associate quality attributes. So if you are making the design decisions which will display the particular quality attributes, you need to have your architecture in that way. Fourth point, enhancing communication among stakeholders. Stakeholder means everyone who is associated with a project or a software application. That is everyone who is involved in it. So those can be user, customer, managers, architects. So software architecture represents a common abstraction of the system that most of the system's stakeholders can use as a basis for creating mutual understanding, negotiating, forming consensus, and communicating with each other. Each stakeholder, customer, user, project manager, coder, tester, and so on, whoever is concerned with different characteristics of the system are affected by its architecture. User. User wants the system to be fast, reliable, and available whenever needed. The customer. The customer wants that the architecture can be implemented on schedule and according to the budget. Manager. The architecture should allow teams to work largely independently, interacting in a disciplined and controlled way. And the architect is a person who is responsible for everything. So he's worried about the strategies to achieve all the goals. The next point, carrying early design decisions. Any design in any discipline can be viewed as a set of decisions. The early design decisions have a strong influence on the final appearance of the structure. Each decision constrains the many decisions that follow. Each decision in isolation might appear innocent enough, but the early ones in particular have disappropriate weight simply because they influence and constrain so much of what follows. Defining constraints on an implementation. An implementation exhibits an architecture if it conforms to the design decisions prescribed by the architecture. It means that the implementation must be implemented as a set of prescribed elements. These elements must interact with each other in a prescribed fashion, and each element must fulfill its responsibility to the other elements as dictated by the architecture. Each of these prescriptions is a constraint on the implementer. Seventh point, influencing the organizational structure. The normal method for dividing the labor in a large project is to assign different groups different portions of the system to construct. This is called work breakdown structure of a system. The work breakdown structure dictates units of planning, scheduling, and budget, inter-team communication channels, configuration control, and file system organization, integration, and test plans and procedures. Enabling evolutionary prototyping. Once an architecture has been defined, it can be analyzed and prototyped as a skeletal system. A skeletal system is the one in which at least some of the infrastructure, how the elements initialize, communicate, share data, access resources, report errors, etc., is built before much of the system's functionality is created. Now, the examples are plug-in architectures. Now, improving cost and schedule estimates. Cost and schedule estimates are important tools for the project manager, both to acquire the necessary resources and to monitor progress, to know if and when a project is in trouble. Architect help the project manager to create the cost and schedule estimates early in the project life cycle. Organizational and work breakdown structure of a project is generally based on its architecture. Each team or individual responsible for the work item will be able to make more accurate estimates for their piece than a project manager. But the best cost and schedule estimates emerge from the consensus between the top-down and the bottom-up estimates. 10th point, supplying a transferable, reusable model. There is a greater benefit if reuse is applied earlier in the life cycle. While code reuse provides a benefit, reuse of architectures provide tremendous leverage for the systems with similar requirements. The code architecture can be reused, and so also the experience and infrastructure gained in building the reused architecture. A software product line or family is a set of software systems that are all built using the same set of reusable assets. The architecture defines what is fixed for all members of the product line and what is variable. The next point is allowing incorporating of independently developed components. Software paradigms focus on programming as a prime activity with progress measured in lines of code. Architecture-based development often focuses on composing or assembling elements that are likely to have been developed separately, even independently from each other. This is possible because the architecture defines the elements that can be incorporated into the system. The architecture constrains possible replacements according to how they interact with their environment, how they access data, and what protocols they use for communication and resource sharing. 12th point is restricting the vocabulary of design alternatives. Engineering is about discipline, and it comes by restricting the vocabulary of alternatives to proven solutions. Advantage of this approach include enhanced reuse, more regular and simpler designs that are more easily understood and communicated, more capable analysis, shorter selection time, and great interoperability. Providing the basis for training. The description of how the elements interact with each other to carry out the required behavior can serve as a first introduction to the new project members. Model views are excellent for showing someone the structure of the project. CNC views are excellent for explaining how the system is expected to work and accomplish its job. Now, these were the 13 points which were important for an organization or a business enterprise. Thank you.